This is one of multiple videos discussing OpenDaylight, Docker, and software-defined networking. One of the great things about being able to virtualize an OpenFlow network in GNS3 is that you can use Wireshark to see what's going on. So in this example, I've got OpenDaylight running on the Ubuntu host. I've connected to the Ubuntu OpenDaylight controller from a Firefox client, but no OpenFlow switches have currently registered. And that's because I've turned off these two OpenFlow switches. So what I'll do is start a Wireshark Capture on the link to the OpenDaylight controller. I'll filter for OpenFlow version 4, which is OpenFlow version 1.3. I'll start up both these Open vSwitch switches and open up a console to the first switch, and there it is, and then I'll open up a console to the second switch. So there are two consoles. OVS VS CTL or VS Kettle shows us that the first switch is connected to the controller. Notice is connected is true. Same command on the second switch. We can see that the switch is connected to the controller. In the GUI, we can see that two switches are connected to the controller. So in Wireshark, we can see OpenFlow messages such as a hello message, features request, port status, and other OpenFlow messages. So what I'll do now is give you a brief overview of some of these messages and how they relate to the OpenFlow specification. On the Open Networking Foundation's website, under SDN Resources, ONF Technical Library, we can see the details about the various versions of OpenFlow. So as an example, I'll look at OpenFlow switch specification 132. This shows us that the wire protocol number is 0x04, and hence we're using OpenFlow v4 for OpenFlow version 1.3. This document shows you a lot of detail, including the fact that an OpenFlow switch has an OpenFlow pipeline. It uses the OpenFlow channel for communication to the OpenFlow controller using the OpenFlow protocol. The OVS VS CTL show command shows us that the switch has a connection to the OpenFlow controller using TCP port 6633. So the local switch is running an agent that allows it to talk to the controller using the OpenFlow protocol. Section 6 of this document shows us the OpenFlow channel and information about the OpenFlow protocol. We are told that there are three types of messages: controller to switch, asynchronous, and symmetric, each with multiple subtypes. So controller to switch includes feature request. The switch will then reply with a features reply. There's a configuration message. There are state modification messages, packet out, barrier, role request, and other messages. Let's start, however, with the first message, which is a hello message. This is a symmetric message, which means it can be sent without solicitation in either direction. They are exchanged between the switch and the controller upon connection startup. Now in Wireshark, I'm going to use the filter OpenFlow v4 IP address 192.168.122.219, and that's because the switch has an IP address of 192.168.122.219. So I'm going to filter the OpenFlow messages to only show me the OpenFlow messages sent and received to this switch. So notice the first message is an OpenFlow hello message sent from the switch to the controller. The switch again has an IP address ending in 219, and the controller is using 149. So we have an Ethernet frame sent from the switch to the controller. The layer 3 protocol is IP version 4, so we can see the source IP address and destination IP address. The protocol is TCP, so protocol number is 6. The source port is an ephemeral port number. Destination port is 6633. That is the well-known port number for OpenFlow. It has changed in later releases of OpenFlow. So in later releases, you'll see port number 6653 as allocated by the IANA. But in this example, we're using the older port number 6633. The higher layer protocol used is OpenFlow. We can see that this is an OpenFlow hello message. So the switch is essentially telling the controller, hello, I am a switch. I'm using OpenFlow 1.3. The next message is a hello message and a features request message from the controller. So notice the source port is 6633, source IP address is 149. This is the controller sending a message to the switch, telling the switch that the highest version of OpenFlow that the controller supports is 1.3. The switch and controller will negotiate to the highest version of OpenFlow that both sides support. In this example, they both support OpenFlow 1.3, so that's the version that will be used for communication between the switch and the controller. We can see that on the switch by using the command ovs-ofctl, or ofkettle if you prefer, dump flows for the bridge. So scrolling up, notice the OpenFlow version used is 1.3. The controller also sends a features request message. It's requesting information from the switch. That is a controller to switch message and allows the controller to request the identity and basic capabilities of the switch. The switch must respond with a features reply that specifies its identity or DPID and the basic capabilities of the switch. So features request. Here's the features reply. This is the data path identifier or DPID of the switch. So the switch is telling the controller its DPID, it's telling it the buffers that it supports and the number of tables that the switch has in the pipeline. OpenFlow switches to be compliant need at least one table in the pipeline. The switch supports 254 tables in the OpenFlow pipeline. It's not an auxiliary connection, it's the main connection. So the auxiliary connection is set to 0. Switch capabilities are shown here. So as an example, the switch supports flow statistics, table statistics, port statistics, group statistics, and other features. You can get the details of these in the OpenFlow specification, but as you can see, we can very easily see the negotiation between the switch and the controller within our GNS3 network. Having a network like this makes it very simple to capture and learn technologies such as OpenFlow and software-defined networking. I hope you found this video useful. If it's been of benefit to you, please like it, and please subscribe to my YouTube channel. I wish you all the very best.